In this module, we're going to take a look at arrays in Java. We'll have a look at the syntax for declaring a variable that refers to an array, and for creating the literal initialization of an array. We'll have a look at how we access elements of an array and the valid range of subscripts that we can use within that. We'll also note that arrays are of fixed size, and we'll learn to determine the length of an array. Sometimes arrays being of fixed size will be a problem, so we'll find out how we can deal with that and make an array that is bigger than the one we started with. Finally, we'll take a look at Java's version of multidimensional arrays. So let's get started by creating a project. We'll call this project Arrays. And the first thing we'll do is to create some very basic code which declares a variable called values, which is described as being an array of int. Notice we take the basic type int and we put the square brackets immediately after it. These two combine to form a single type declaration that says values is an array of int. Then we initialize this by using this literal format for declaring an array, where we take curly braces and then we put a comma-separated list of values within the curly braces. Finally, we close the curly braces and put a semicolon on the end of the line to complete it. So now values describes an array of integers containing the values 1, 1, 2, 3, 5, 8, 13, 21, and 34. The next thing we need to be able to do is to actually use one of the elements of the array. The way we do that is simply to take the array's name, values in this case, put square brackets after it, and to put an expression that describes a number, which will be the element number within that array. So values subscript 4, these subscripts always start at 0. So this would be the subscript 0, this would be subscript 1, this would be subscript 2, this would be subscript 3, and this will be the element at subscript 4. In other words, values square brackets 4 is really the fifth element of an array. So we would expect this to print out the value 5. So let's run this program. And we see indeed the fifth element of values is 5. If we were to change this to the value 5 and make this 6th, then we should see that we pick up the value 8. And indeed we do. The next thing we need to know is that if we try to access an array element that does not exist, then we will get a problem at runtime that we will need to fix. So in this case we have 9 elements in there, and if we were to try to access element with subscript 10, which would really be the 11th element, this will actually cause the program to fail by doing what's called throwing an exception. And you'll see this exception in thread, array index out of bounds exception, and the number 10 is the subscript that was given to it that it didn't like. If you click on this little piece, by the way, if I move the cursor away from there, notice how the cursor is currently here. I click on here and that actually moves to the line where the error occurred. So NetBeans has this quite useful feature for determining where the problem actually arose. So let's put this back to something that works. We'll go with values 4 and we'll make this the 5th element. Given that we are restricted to accessing elements that actually exist, and that the elements start at subscript 0, we need to know sometimes how many elements there are in an array. So it turns out that if we put this expression .length on the end of the name of an array, so here we have values .length, the array itself knows how many elements it has, and we can effectively ask it. So in this case, if we run this, we'll see that there are 9 elements in values. Remember that the elements will be numbered 0 through length minus 1. So the valid subscripts are from 0 to 1 less than the value of length, so in this case up to 8. If we want to print out all the elements of an array, we can use a loop to do that. So here, notice we use a for loop. We start off with an index value of 0. And then while the index is less than the length of the array, we will print out that particular value with that subscript. And then each time round the loop, we will increment that subscript value. So here we will expect to print out each of the elements of the array in turn. And as you can see, it prints out values 0 is 1, values 1 is 1, runs its way through the elements. Subscript 8, which is the 9th element, prints out 34. In addition to being restricted to accessing the elements of the array that already exist, Java's arrays are also of fixed size. So we can't add new elements to an array. So for example, if I were to attempt to set values 9 to 55, that's not going to work. We'll actually get the same error that we would get if we tried to read the value of values 9. Interestingly, the exception is not always printed out in sequential order with the problem that caused it. The reason for that is simply because the error stream is a separate channel from the output stream, and in consequence these things arrive at the console sometimes in the strange order. But you'll see here it's complaining that we cannot access the element number 9, subscript 9, of an array that only has 9 elements, which are therefore numbered 0 to 8. So that doesn't work. So what happens if we have an array and we need to add more elements to it than it already has? The way we have to handle this is actually to create a new array, and we do that like this. We declare a new variable, and then what we do is we say equals new int square brackets, and inside the square brackets we can specify the number of elements we would like this array to have. Now we actually can do this at any time. There's nothing special or unique or reserved about this, special to creating a larger size of array. But what this does is to create a new array, and interestingly all the values in this, which will obviously be the subscripts 0 through 19, because this is a numeric array, all the values will be set to 0. Then what we can do is we can copy the existing array into the new array. And for this we have a special mechanism provided by Java, system.arrayCopy. You can probably guess we could do this by hand with a loop, but that would be potentially less efficient than this. So the way system.arrayCopy works is we specify the array we are copying values from and possibly an offset within that array. Well, we want to start at the beginning. Then we specify the array we are copying values to, and again an offset within that array, and then the number of elements that we want to copy. In this case, all the elements in the values array. Having done this, we'll contain all these elements from the original values array, but also will contain additional elements all at the value 0 up to the subscript 19. Now that we have a longer array, we can add the additional values to it. So now we can set the value of more values 9 equals 55, and then we can print out more values 10 if we want to, because that value exists even though we haven't set it to a special number, therefore it will have the value of 0. So here you can see more values 10 is 0, and this assignment of more values 9 did not cause a problem like it did before. Many programming languages provide multi-dimensional arrays. In some ways you could look on Java as the same in that we have the ability to use something that looks like multi-dimensional arrays. Technically, it actually isn't considered as providing multi-dimensional arrays. What we do get, though, are arrays of arrays. And they're very similar. They'll do everything that multi-dimensional arrays will do, but they're also subtly different. So here, remember we said that when we put the square bracket after the int, that meant that the variable we were about to name was an array of int. Well, here we've got a square bracket after the square bracket that's after int. And the way to read that is that this is an array of whatever comes to the left of it, which in turn is array of int. In other words, it amounts to a two-dimensional array. But what we discover is then when we define the array, we provide the curly braces that introduce the definition of the array, but then the elements of the array are not numbers. The elements of the array are actually arrays themselves, and these are arrays of ints. But you'll notice that here this array has 3 elements. This array has 2 elements, and this array has 4 elements. Because this is not a multi-dimensional array, but is actually an array of arrays, that's perfectly okay. You still access the elements within these arrays of arrays the same way you would have done for simple arrays. So in this case, ragged matrix 0, 2 will pick up, first of all, ragged matrix is the whole thing. Ragged matrix 0 refers to this whole array. Ragged matrix 0, 2 is therefore element 0, element 1, element 2, and should print out the 3 that we have here. So if we run this one, we should see ragged matrix 0, 2 is 3. So in this module, we've looked at the declaration of arrays, the initialization of arrays, accessing the elements of arrays, the length of arrays, how to iterate over arrays, what happens when you don't have enough space in an array, and how we can handle multidimensional arrays in Java.